the next step in studying three-dimensional curves. Right? We studied curvature, and now we can look back at what we studied about curvature and how we studied it, and apply that to the new concept of torsion. Just to begin with, to determine what it is and how to measure it, because we would like to measure it. Well, especially when it is so related to to how people fly, right? And how to build those jets. So, what is it? Remember what we thought about the curvature? We thought about the tangent line changing, and then as it changes direction, and we measured the angle between the adjacent tangent lines, and we related that angle to the distance traveled, and that rate of change was the curvature. Now, in 3D, it is not only that the tangent line changes, which determines the curvature again, but also the osculating plane changing. Right? So if the osculating plane changes, then the position of that plane at one moment and position at the other moment, those two are different by an angle again. Right? Those two different planes have some angle between them. And then, what does that make sense to measure? Isn't it that we measure the angle between those two planes and relate it to the distance we traveled? Right? And then we say the greater that ratio is, the greater the torsion is, because the faster we change the plane, the greater that ratio is supposed to be. Right? So the torsion is, our first simplistic idea is torsion to be, of course, limit, right, as distance traveled going to 0 of the angle between osculating planes related to the distance traveled. And here I'm taking the purely geometric point of view. There is no physics involved. But when you see the fighter jet flying, you first think about physics probably, right?